Have you ever really thought about what's happening inside your phone when you're juggling a dozen apps and browser tabs? Well, there's a silent war being fought every single second for one of the most precious resources on your device, memory. And it turns out your phone and your PC have completely different, totally fascinating battle strategies.
You know that feeling, right? You switch back to an app on your phone, and poof, it has to reload from scratch. It's frustrating. But on your PC, that very same app would probably still be right where you left it, even if the whole system felt like it was wading through molasses. So why the difference? Why does one device kill and the other just chug? That's the exact mystery we're going to solve.
So here's our game plan. We'll start with the mystery, then dive into the traditional Linux swap philosophy. After that, we'll look at Android's radical compress and kill strategy. We'll put them head-to-head on performance and longevity, unravel the virtual RAM twist, and finally, look at what this all means for the future.
All right, let's kick things off with the classic, the established champion. The philosophy that has been powering desktops and massive servers for decades. Its core principle is simple. Hoard everything. Never, ever throw data away if you can possibly help it.
So how does it pull off this hoarding strategy? Well, the secret weapon is something called swap space. The operating system basically carves out a chunk of your much slower, but way bigger, storage drive, your SSD, and tells the computer, hey, treat this like an extension of our super fast physical RAM.
The best way to picture this is like an overflow parking lot right next to a giant stadium. The main lot, that's your RAM, is fast, convenient, right by the entrance. But when it fills up, the attendants start sending cars to the overflow lot way out back. That's your swap space. Sure, it's a long, slow walk to get your car back later, but hey, at least you didn't get turned away at the gate.
Now, under the hood, there's this little process called K-swapped. And its whole job is to watch for data that isn't being used much and shuttle it over to that slow storage. There's even a setting called swappiness that lets you fine-tune how aggressively it does this. But the goal is always the same. Maximize capacity and keep every single program running, no matter what.
Okay, now for the challenger. Android came along, looked at the mobile world, with its tiny batteries and fragile storage, and said, no way. The traditionalist approach just won't cut it here. It needed a completely different and, frankly, a much more ruthless strategy.
Android's secret weapon is called ZRAM. And this is the part that's so cool. Look at where it lives. It's not on your phone's storage. It's a virtual swap space that's created inside your existing super fast RAM by compressing data on the fly.
And this analogy just nails it. Instead of moving your extra clothes to a whole separate storage unit across town, you just vacuum seal them to cram more into the suitcase you already have with you. Yeah, it takes a little bit of effort, some CPU cycles to compress and decompress everything, but it is way faster than writing to and reading from your phone's storage.
But compression isn't its only trick. Android has this whole escalating response system. When memory gets tight, first it tries to compress inactive stuff into ZRAM. If that's not enough, it'll politely ask the running apps, hey, could you maybe trim your own memory usage a bit? And only when all else fails does it bring out the big guns.
And that final step is the low memory killer daemon, or LMKD. And seriously, think of it as a ruthless nightclub bouncer. Its one and only job is to protect the VIP, that's the app you're using right now. And to do that, it will not hesitate to find the least important apps hanging out in the background and just kick them to the curb. That's why your app has to reload when you switch back to it.
So we have two totally different philosophies. Hoard versus kill. How do they actually stack up when you put them in the ring together? Let's find out. At the end of the day, the fundamental difference comes right down to this. Android's ZRAM is doing a really fast compression operation entirely inside your phone's lightning-fast RAM. Traditional Linux swap is doing a very slow writing operation to your device's much slower flash storage. And the difference in speed? Well, it's just staggering. Just look at this. It's wild. Accessing RAM, even compressed ZRAM, is measured in nanoseconds, billionths of a second. But the moment you have to go out to your flash storage, That jump takes you all the way into the world of microseconds.
And let's be crystal clear about what that means. A microsecond is 1,000 nanoseconds. That makes ZRAM up to 1,000 times faster. This enormous latency gap is the absolute core reason Android will do almost anything to avoid writing to storage.
But, it's not just about raw performance. There's another huge reason, the longevity problem. The flash memory cells in your phone and your fancy SSD, they can only be written to a limited number of times. We're talking maybe 3,000 to 10,000 write cycles before they start to fail. A traditional swap system, constantly writing and rewriting data, can literally wear out your device's storage, shortening its lifespan. Android's whole philosophy is built to avoid that exact problem. So when you lay it all out like this, the two strategies are just night and day. Android stays in RAM, it's all about being fast and being gentle on the hardware. The traditional approach uses storage to get the absolute maximum capacity, but it pays a steep price in both speed and long-term wear and tear.
But hold on, the story doesn't end there. In just the last few years, phone manufacturers have introduced a massive plot twist, and they're blurring the lines between these two philosophies with shiny marketing terms like virtual RAM.
So if you've seen features on your phone called RAM Plus or memory extension, this is exactly what's going on. These companies are actually reintroducing a small traditional swap file back onto your phone's storage. It's meant to be a final, last-ditch safety net that only kicks in after ZRAM is totally full, all in an attempt to kill fewer background apps.
The technology that makes this possible is a really clever kernel feature called ZRAM Writeback. What it does is, it intelligently finds the oldest, most stale compressed data that's just sitting in ZRAM, and when your phone is idle, it quietly moves that data out to the slow storage swap file. This frees up precious ZRAM for more important active tasks.
So, the big question, is this hybrid approach actually a good idea? Well, it's a trade-off. For phones that don't have a lot of physical RAM to begin with, it can genuinely help keep more apps open in the background. But it comes with the exact costs we just talked about. You risk performance stutters when that slow storage has to be accessed, and you're definitely increasing the wear and tear on your phone's hardware.
So, after all of that, what's the big takeaway? What have we learned? We've got these two very distinct philosophies, born from completely different worlds, that are now starting to collide and even merge.
At its absolute heart, this has always been the fundamental trade-off. Android, the mobile specialist, sacrifices the ability to keep every single app alive in order to deliver snappy, predictable performance and protect the physical device itself. Meanwhile, traditional Linux, the old-school traditionalist, sacrifices some of that instant snappiness in exchange for enormous capacity and the flexibility to run huge, demanding workloads. And that leaves us with a fascinating and really important question for the future. As our laptops become more like our tablets and our phones become more powerful than our old desktops, which philosophy is going to win? Will all of our devices eventually become ruthless minimalists like our phones, prioritizing that immediate experience above everything else? Or will hardware just keep getting better, giving us so much fast, durable memory that this whole debate about hoarding versus kitting just becomes irrelevant? The memory war, it seems, is far from over.